Okay, solution stoichiometry. Do you remember stoichiometry? The deep recesses of your brain. That was grams to moles to moles to grams, right? Well, if we have a reaction that involves aqueous reactants or products, it can be more convenient to specify amounts in terms of volume and concentration. So we can use the volume and concentration to calculate the moles of the reactants or the moles of products and do stoichiometry that way. So the general solution map here is that you have a volume of something and you go to moles of that and then to moles and then to a volume. So it's a little bit different than grams to moles to grams, and yet it's related. Because before we did grams here and grams here. We need a different color. So we're adding some variation here. You can go from volume to moles to grams. You can go from grams to moles to volume. So let's do some examples. Here is an equation, a balanced chemical equation. How much 0.125 molar sodium hydroxide solution do we need to completely neutralize 0.225 liters of 0.175 molar sulfuric acid solution? We're going to approach this the same way we approached stoichiometry before. We're going to use that balanced chemical equation as a way of organizing our information. So 0.125 molar sodium hydroxide, that's a concentration. I'm going to write that under the sodium hydroxide. So 0.125 moles per liter. And then it tells me the concentration of the sulfuric acid is 0.225 moles. Nope, sorry. Call that a brain fart. Okay, that was the volume. That's liters. It's still in the right place. It's for the sulfuric acid. 0.175 moles per liter. So there, I took all the numbers in there and wrote them under the chemical formulas that they relate to. The middle of all stoichiometry problems is moles to moles. So if you're getting a little lost, then you can always start in the middle. Say, okay, well, I need to do moles to moles. What am I trying to find? How much of that sodium hydroxide solution? Well, that's going to be a volume. So I'm trying to find question mark liters about the sodium hydroxide. So at the end here, I want to have liters. That's what I'm trying to find. What am I given? Well, they gave me two numbers about the other thing. They gave me a volume and they gave me a concentration, molarity. Moles per liter. Anytime you have a unit per another unit, that's probably supposed to be used as a conversion factor to convert between moles and liters. So I'm not going to use this one to start with, I'm going to start with that one. So I'm going to start with liters, and I'm going to convert to moles. I'm going to convert to moles of the other thing, and then I'm going to convert to liters. So 0.225 liters of sulfuric acid, and I'm going to multiply by moles. Gets a little tedious sometimes writing in all these formulas. And you feel like, I'm going to run out of room. Yeah, I might run out of room. And then we're going to go to moles of sodium hydroxide, and then to liters of sodium hydroxide. It's smaller and smaller. So I got the units on the top from my path. Now I'm going to put units in the bottom to cancel out all the units I don't want. So start at the beginning. So over here I'm going to have liters of sulfuric acid so that those cancel out. Here I'm going to have moles of sulfuric acid so those cancel out. And then down here I'm going to have moles of sodium hydroxide so those guys cancel out. Now, instead of using molar masses that we have to calculate, we're going to use the molarity which was given to us. So there's less calculating in these. So for sulfuric acid, it was 0.175 moles per liter. So the 0.175 goes with moles, 0.175 moles per liter. If you want to, you can put a 1 down there. The middle term, we do the same as we did in that earlier chapter. We look at the balanced chemical equation. In front of sulfuric acid, there's no coefficient. In front of sodium hydroxide, there's a coefficient of 2. So those are the coefficients that we put in here. 2 for the sodium hydroxide. You can leave the 1 off, or if that bothers you, put a 1 in there. Then this last one is moles per liter, but upside down. But we're given the concentration 0.125 moles per liter. It's not going to fit, so I'm going to write it in like this, 0.125 moles of sodium hydroxide per liter. What a mess. So then we get out our calculator, 0.225 times 0.175 times 2 divided by 0.125 equals. And the calculator says 0.63. But how many significant figures should that number have? It should have 3, right? Because all the measured numbers we were given had 3. These guys in here only have 1 digit, but those are exact numbers. So what I have to do then is be smarter than my calculator and put a 0 on there. So that is the volume of sodium hydroxide that is needed. Any questions?